This video is an in-depth explainer for SAT Practice Test 9, Section 4, Question 24. And I had done this problem on my the full Practice Test 9, Section 4 video, but I received a comment on it asking for a little more clarification, and also just noticed that it's getting a lot of watch time. So I want to do this in-depth video, make sure the concepts are perfectly clear to everybody so that you'll ace it when you see something similar on your SAT. Okay, so the problem is if f of x is equal to 5x squared minus 3 and f of x plus a is equal to 5x squared plus 30x plus 42, what is the value of a? And I'd bet what's tripping most students up on this problem is seeing this f of x plus a appear here. You know, you're just not used to seeing this every day. You're used to just seeing straight f of x like you have over here, or f of y, f of a single variable, basically. But the good news is we can fix that. You can make it into that single variable that you're used to seeing. We can just redefine this second equation here as f of z. So f of z is equal to 5x squared plus 30x plus 42. And that's valid as long as you retain the information. You can make yourself another equation that this z is equal to x plus a. And how does that help you? It helps you because the first equation that you're given is in that nice form you're used to seeing, just f of x. And as you know, that f of x, you can plug anything you want in for x, any constant, and it would be valid. You can plug in 0, you can plug in 10, you can plug in 1,000. This equation will hold true. So in this case, we're going to plug in another variable. We're going to plug in that z that we just defined. So you can make this now f of z is equal to 5. Again, we're plugging in, so we plugged in z here. We're going to plug in z here. 5z squared minus 3. And now we're going to use that z as we defined it up here. So that z is equal to x plus a. Plug it right in to give you f of z is equal to 5 times x plus a squared minus 3. And what's great is that now we have two equations that are the same on the left-hand side, right? From our second equation that they gave us in the problem, we have f of z is equal to this 5x squared plus 30x plus 42. And we also have separately from the first equation that they gave us, this f of z is equal to 5x plus a squared minus 3. Because the left-hand side of both of those equations is the same, we can set them equal to one another. So we'll do that up top here. Starting with that 5x plus a squared minus 3 is equal to the other expression, 5x squared plus 30x plus 42. Now it's easy to see we have an equation that has x's and a's, and we need to solve for a. And in my previous video, I expanded out this x plus a squared, crossed out x's, and then finally solved for a. And you can do that. That's perfectly valid. What I've realized in recording this video is that there's actually an easier way. So this equation has to be valid for all values of x, right? Including x is equal to 0, which means you can plug in 0 for x right now, which, just like in a lot of problems, plugging in 0 for x makes everything easier. So you can go ahead, replace this x with a 0, replace this 5x squared with a 0, and replace this 30x with a 0. That leaves you with 5a squared minus 3 is equal to, everything else is gone, just 42. Add 3 to both sides. You have 5a squared is equal to 45. Divide by 5 on both sides. That'll leave you with a squared is equal to, this is a calculator section, so if it's simpler for you to do it in calculator, go ahead, do it, but it's 9. A is equal to the square root of 9. Again, plug in your calculator if you want, or just know that a is equal to 3. Square root of 9 is 3. So a is equal to 3. The problem is asking what is the value of a. 3 exists as c. So C is your correct answer. So that answers the problem. I want to conclude this video with one more thing, which is that to get a real grasp of this concept, you won't be able to do this on the SAT, but it's helpful to plot both of these expressions, f of x squared minus 3 and f of x squared plus 30x plus 42. So let's go ahead and do that. If you were to go to a site like Wolfram Alpha, or do it on your graphing calculator and just say plot 5x squared plus 30x plus 42 and plot 5x squared minus 3. This output here is from Wolfram Alpha. You'll get this plot here. This is the same plot. The top one's just zoomed in a bit. So let's look at the bottom one, which has the blue is that f of x expression, and the magenta here is that f of x plus a expression. And what you'll see is they're both parabolas, right? That makes sense. They both have quadratics here. They're both parabolas. And it looks like they're parabolas that are offset from one another. And you can see that more clearly in the zoomed in version up here. So if you look at the f of x expression, it has its vertex. The easiest point to pick out on a parabola is its vertex. So its vertex occurs at x is equal to 0. Now on the number line, if you jump back, how much is it offset by? It's offset by 1, 2, 3 units, right? The vertex for the x plus a occurs at x is equal to -3. So that shows that what this f of x plus a, they're just asking what is a, what is the offset between these two plots, and it's 3, right? The f of x is offset 3 from this f of x plus a. And that's all they're asking for. And I bring that up not because that helps you for this particular problem on the SAT, but now you have that in your head, that if they give you one of these crazy, functions with an expression inside the function, all they're asking you for, and it might help orient you a little bit, is what is that offset by? If this is a constant, what is it offset by some constant on the plot line? Hope that helps. Hope it's kind of an aha moment. But overall, I hope this video helped a lot, made it a little bit clearer. If there are still questions, please leave a comment. I'm totally open to even making another explainer video, or maybe just explaining things in the comments themselves. Check out my other videos. I love making explainer videos like this. If there's any other problem on any other practice tests, let me know and I can do one of these in depth. Because if you have a problem, odds are 100 other students also have the same question, and I'd like to get a video out there just to help everybody. So thanks a lot for watching. Hope you do great in your SAT.